Hello everyone, and welcome to this presentation on building and configuring the front-end part of the OCI Serverless MachaOn application. Before we dive into the front-end configuration, it's important to note that the backend module contains multiple OCI functions pivotal to the application's functionality. As described in the first part of the OCI FOS MachaOn presentation, you need to ensure that all necessary OCI functions, such as login, registration, user, products, order, and authorizer, are properly created and deployed. These functions are critical for handling backend logic and API interactions. Once the backend is fully set up and deployed, we move to the front-end configuration to complete the application. The front-end for this project is a custom implementation based on Machb project front libraries, providing a scalable and intuitive user interface. It has been tailored to include key features such as JWT-based authentication, ensuring secure and modular integration for a modern web application. To start, you'll need to set up the front-end by cloning the MachaOn front-end project. After setting up the environment, you'll build the project and prepare it for deployment. Once built, you can run the application locally to test it before deployment. To build the MachaOn front-end, the first step is to ensure that Node.js is installed on your system. The Machanism project requires a specific version of Node.js to ensure compatibility and functional stability. We recommend using Node.js version 22.18.0 or a compatible version, as older versions may lead to unexpected issues. After installing Node.js, verify the installation by checking its version to ensure everything is set up correctly. Once confirmed, run the install command to download all the necessary project dependencies specified in the package configuration file. After the dependencies are installed, execute the build command to compile the project and prepare it for production. These steps ensure the front-end is ready for deployment or further testing. Now let's talk about configuring static website hosting using OCI Object Storage and an API gateway. This process involves securely uploading your website's static files to object storage and providing public access through a secure HTTPS endpoint. First, you'll start by creating an object storage bucket in the OCI console. It's important to ensure the bucket's access type is set to private for security purposes, as public access will be managed through the API gateway. Once the bucket is created, the next step is to upload your website files. Begin by adding essential root files like index.html and favicon.ico. After that, bulk upload additional directories such as CSS, JS, fonts, and other static asset folders. These files are crucial to ensure your website renders properly. To streamline the upload process, you can either manually upload the files or use a pre-configured script that automates the entire process. The script ensures all necessary files are uploaded in the correct folder structure, making it easy to host your website. Before running the script or uploading files, make sure that your OCI CLI is configured correctly, and all required environment variables are set. This setup ensures a smooth and efficient upload process, readying the files for public access through the API gateway. Now that we've configured the static website hosting, the next step is to validate the upload process to ensure everything has been successfully transferred to object storage. Start by checking the object storage bucket in the OCI console to confirm that all files and folders, such as the index.html and asset directories like CSS, JS, and images, are present in their correct paths. This step is crucial to ensure the website structure is intact and accessible. The next step in our process is to create a front-end gateway using Oracle API Gateway. This gateway serves as the secure entry point, allowing HTTPS requests to access the static website files stored in object storage. To begin, navigate to Developer Services API Gateway in the OCI console. Once there, create a new API gateway and attach it to your Virtual Cloud Network, VCN. By connecting the gateway to the VCN, you ensure secure communication between the gateway and the object storage bucket. After the gateway is created, deploy an API route in the gateway settings. This route maps incoming requests, such as /index.html or other static file paths, to the corresponding files in the object storage bucket. By deploying the route, the gateway enables seamless routing of requests to your static files, ensuring proper access for your website visitors. With the front-end gateway configured, your website is now accessible through a secure HTTPS endpoint, ready for public use. To enable external access to your application in Oracle Private Cloud Appliance, we need to set up an Internet Gateway. The Internet Gateway allows resources in your virtual cloud network to communicate with external networks, such as the public Internet. The configuration involves two critical steps. First, you'll add an ingress rule to the security list for your VCN. This rule allows inbound HTTPS traffic on TCP port 443, ensuring secure and encrypted connections for your web server or application. Next, you'll create a route rule in the VCN route table. This rule directs all internet-bound traffic, defined using the special CIDR block, to the Internet Gateway target. The route rule ensures that traffic not covered by other rules is properly routed through the gateway. It's important to note that without these ingress and route rules, inbound connections, including HTTPS requests, will not work. The next step in our process is configuring the API gateway to act as the secure front-end interface for your OCI functions. This setup ensures seamless routing of API calls from your front-end to the backend functions. First, log into the OCI console and navigate to API gateway. Create a new gateway by providing essential details such as the name, the compartment it will reside in, and the subnet within your virtual cloud network. Once configured, the gateway will act as the entry point for all API requests. After the gateway is provisioned, it's ready for deployment. Next, create a deployment. This deployment allows you to define API routes that connect to specific OCI functions. You'll name the deployment, specify the route path, like /API, and configure individual routes. For each route, define the path, HTTP methods, such as POST or GET, and point it to the corresponding OCI function. You can either browse for the function or enter its unique OCID. To ensure the security of API calls, apply authorization policies using an authorizer OCI function. This function validates requests before routing them to the backend. Once your application is set up, the final step is to test it to ensure everything is working as expected. Testing the application involves calling the front-end gateway directly from a browser and verifying that the API routes and functions behave as intended. To specifically test the registration flow of the application, we will verify not only the front-end behavior but also the back-end functionality, ensuring that new user data is being correctly processed. Once the registration form is submitted through the application, it triggers the corresponding registration API route, which invokes the OCI function in the backend. To validate the backend success in handling the request, we'll open the Commerce Tools Merchant Center and check whether the new user has been successfully created. This will confirm that the registration data was processed correctly and stored in the Commerce Tools system. To test the login flow, we'll begin by filling out the login form with valid user credentials and submitting it. Once submitted, the front-end sends the login details to the API gateway, which invokes the corresponding login OCI function in the backend. If the credentials are valid, the backend will generate a JWT token and return it to the frontend. As a result, we'll display the token in the browser's debug console, allowing us to verify that the authentication process is working correctly. This token can then be used for secure communication in subsequent API requests, ensuring that the user remains authenticated throughout their session. Finally, we'll test the order submission flow using the JWT token for secure communication. Once the user is logged in and authenticated, their JWT token is included with the order submission request. When the order is submitted, the API gateway forwards the request to the order OCI function, and the authorizer OCI function validates the token to ensure the user is authorized to perform this action. If the JWT is valid, the order is successfully processed, demonstrating the secure interaction between the front-end, API gateway, and back-end. Thank you for watching. Stay tuned for future videos where we explore the finer details of building robust MachaOn projects in Machanism. And as always, remember, divide and use.